Once again, I want to welcome you. I want to take this opportunity to recap the work that we have already done thus far so that you can remember. We have been estimating and formulating a regression model. I will advise that you mute yourself now so that you don't disturb everyone. Mute yourself. If you have a question or anything, you raise your hand. We have been formulating this ZMax work. This is Farm Milk Ghana Limited. That makes 40 Ghana cedi profit if they should sell 1 sachet of Fanyago, and makes 50 Ghana cedi profit if they are to sell 1 unit of Fan Choco. Therefore, the 40x1 is the total profit from all the Choco, whereas the 50x2 is the total profit from the total Choco sold. This is subject to, it's an optimization model that is subject to what I'm about to give you now. So we are optimizing this objective function. Remember, the Z value is a profit and the Z function is objective function. This is subject to a certain constraint. The first constraint is the labor constraint. The labor constraint is given by 1x1 or x1. And normally add the 1 because for some people, they forget that this is that 1x1 plus, and that 1x1 represents 1 hour of labor used to produce yogo, and then 2 hours of labor used to produce choco. So these are the usage used. That is the left-hand side. And then there is a sign which is less than 40 hours. Now, why less than or equal to? The less than or equal to indicates that the 40 hours on the right, all of it can be used. So you may use all the 40 hours to produce the Fan Yogo and the Fan Choco. And if you use all the 40 hours, then we are dealing with equal to sign, equal to sign. But it is also possible that the company members will not use all the 40 hours. If they do not use all the 40 hours, which is also possible, then we are dealing with less than 40 sign. So we have a symbol of less than. So the overall less than or equal to symbol is representing optimum utilization, total utilization of the 40 hours, or less than the full utilization of the 40 hours. All right, there's another constraint, which is a milk constraint. Okay. The milk constraint, according to the story that we looked at last time, it is 4x1 plus 3x2. What is 4x1? 4 gallons of milk are used to produce a sachet of Fanyago, and 3 gallons of milk are used to produce a sachet of Fan Choco. And there are how many gallons of milk available? The word available means that we are going to have the sign to be less than or equal to. We have 120 gallons of milk available. So these are the two main constraints. The other constraint we are about to talk about is a default constraint, and that is the non-negativity constraint. It's not really an important constraint such as, like when we talk about the constraints of the model, we are not including the non-negativity constraint. That non-negativity constraint says that we want everything to be positive or at least 0. In other words, we don't want a negative value for Choco or a negative value for Yogo. So this is a model that we had, okay? Now, on the basis of this model, I have some questions to ask you. And today is all about you asking me questions or me asking you questions. It's not about anything. So I'm about to ask you your first question. And the first question I'm asking you is, why is the sign less than or equal to and not equal to? The constraint sign. Why is it less than or equal to? Raise your hand. Or not equal to? Najele.
It means that it's possible that we will not use all of the 40 hours or the 120 gallons. Maybe we will not optimize production, so we may use less, or may use the 40 or the 120.
You have mixed things. It is possible that we will not use all the 40 hours of the 120 gallons.
No, you didn't hear me. So I'm saying that, okay, let's say labor.
Maybe you are far away from the microphone. Can you talk into the mic?
Yes, I am. Can you hear me, please?
Yeah.
So I'm saying that if we take the labor constraint, it is less than or equal to because in the organization, it is possible, so at Fundilk, it is possible that they may not use the full 40 hours. Maybe they will not optimize the labor. And so it is possible that they may use less than 40 hours, or they may work efficiently and use the full 40 hours. That's why it is less than or equal to.
All right. Okay. That's it. That's the reason. All right. The next question I'll have for you, unless you have a question for me, is how many resources are there in this company? You can tell me how many resources are there. Now you can choose to sit down throughout this whole course and not talk. It's an enjoyable area to be. And you can also choose to be in this class and talk throughout. The justification, the consequences of each will be clearer in due course. Pius.
Doc, please, we have 2 resources.
Are they limited or they are not limited?
Hello, Doc.
Are they limited or they are not limited?
They
are limited.
They are limited.
Ladies and gentlemen, there's a reason why I want everybody to mute yourself. All right. Let me go to the next question. How many hours of labor are required to produce fine yogurt? You can tell me. How many hours of labor are required to produce fine yogurt? Those of you who have unmuted yourself, please keep yourself muted. And Miriam, I think the best you can do for me here is keep muting people that I have not asked them to mute. Okay. Florence, should I mute you forever? Florence.
No, my network was acting up.
All right, so who can tell me? Miriam, Josephine.
1 hour, please.
1 hour. Okay. So that's wrong. How many hours of labor are required to produce fine chocolate? Ebenezer.
2 hours.
Okay, so what I'm going to do is I'm going to mute all of you. Okay, since you don't understand instruction of not talking into the air, I'm going to mute everybody. You can't unmute yourself until I allow you, because it looks like you don't follow instruction. Okay, so like I said, how many hours of labor are required to produce fine chocolate? And I think I called Josephine. Yeah, Josephine.
2 hours.
2 hours. Okay. All right. So the question is, how many hours of labor are required to produce all the fine chocolate? I'm not getting the right answer. The rest of you can type the answer in there. How many hours of labor are required to produce all the fine yogurt? And that is 1x hours. 1x hours. 1x1. 1x1. There's a reason why it is 1x1 and not 1. 1x1, not 1. Because that is the total. So we are talking about all of this. Okay. Now let me go quickly to the next one. How many hours of labor are required to produce all the fine chocolate? How many hours of labor are required to produce all the fine chocolate? That is 2x2 hours. Judy, that's the correct answer. Okay. Now, what is the total hours? What is the total hours used by Fan Milk Ghana Limited? What is the total hours used by Farm Milk Ghana Limited? Michael Abuaje, what is the total hours there? The total hours used by Farm Milk Ghana Limited.
Hello, sir, please, can you hear me?
Go ahead, yeah.
So the total hours will be 1x1 plus 2x2.
Perfect. That is it. That is the total hours used. Now, how many gallons of milk are required to generate the entire choco? How many gallons of milk are required to generate the entire choco? MKK.
Doc, I have a question for you, but I will just have to answer the question first. It's 4x1 plus 3x2.
Okay, that is wrong. Ask your question now. That is wrong though, but you ask your question.
120 gallons, sorry, 120 gallons. But my
it's still
question
wrong,
is,
but you go ahead with your question.
Why do we have 2x1 and not 2x2?
This is from the story. Okay, so that's a typo. 2x1 is a typo. It's supposed to be 2x2.
Thank you.
All right, okay. So the total gallons of milk required to produce fine choco is a 3x2. All right, we've looked at this already last time, okay? What we are going to do today, more importantly, what we are going to do today is to find the decision variables, the DV. The decision variables are the x1 and then the x2. We are going to find the value. So the main problem is, what is the optimal solution? Write it down. What is the optimal solution? The optimal solution is made up of both the x1 and the x2. And how do you find it? There are three ways to finding it: graphical approach, mathematical approach, and computer approach. Today, we want to quickly look at the graphical approach. So the first thing is to draw the constraints. There are two main constraints, but there is a non-negativity constraint. There are two main constraints, but there is also the non-negativity constraint. The first to draw is a non-negativity constraint. The first to draw is a non-negativity. So how do you do that? Okay, take your Cartesian plane, okay, your Cartesian plane, and then indicate your y-axis, and then indicate your x-axis. So your y-axis, and then your x-axis, very nicely. Once you've drawn that, label them. The x-axis, we are calling it x1. The y-axis, we are calling it x2. Because these were the decision variables. Now, we cannot draw x3 in addition to this. that will require a polyhedral or a surface plot, and you won't understand here. Now, the first thing to do is to, this whole thing that I've just drawn is a non-negativity constraint. Remember, the non-negativity constraint says that the x1 and the x2 should be 0 or positive. And you can see the corner point here means they are 0. Done. The next is to draw this constraint, which is x1 plus 2x2 less than or equal to 40 hours. So we are going to draw this. Now, to draw this, you have to assume the maximum. To assume the maximum, the only way you can assume the maximum value is to make this less or equal to. So we're going to make this one equal to. When you make it equal to, what does that mean? What it means is that we are saying that the left-hand side equals the right-hand side. That's what you're saying. Okay, so that is the maximum hours on the left, which is 40, equals the maximum hours on the right. So that will be a line. And then the less than will be the space. Write it down somewhere, you'll forget. That the equal to indicates the boundary of the space, whereas the less than indicates the space. So if I show a space, for example, if I draw a triangle like that, this triangle has got the boundaries, 3 boundaries. The boundary is the equal to. The space is the less than or equal to the inside. And that is it. So I can use equal to actually find this. This is an equation of a line. When you look at it carefully, it is equation of a line. It's just like y equal to mx plus c. And so all I need are 2 points to draw this line. That's all. Equation of a line. I just need all this to draw this point. So you just indicate x1 plus 2x2 equal to 40. How do you get the first point? Assume that x2 is 0 or x1 is 0. So let's start with x1. So if x2 is 0, what will be x1? Who can tell me? If x2 is 0, what will be x1? Okay, I got an answer from Kwejo. It says x1 will be 40, and that is correct. Okay. Now, those of you who don't understand this, you have to go and refresh your Akiola book that I told you to write and refresh your equations and inequalities and word problems. Okay. Now, the answer will be 40. If x1 is rather 0, what will be x2? If x1 is rather 0, what will be x2? And I'm getting fantastic 20. Okay. So that is good. So that means that x2 is going to be 20. So watch it. x1 is 40. So look for x1 here and identify 40. Ah, that is good. So that's 40. We can identify anywhere here and call it 40. And then x2, okay, if x1 is 0 here, x2 will be 20. So identify anywhere here and then call it what? 20. So you write 20 here. What you have to do now is to join them, the 20 and the 40, because that is what gives you the equation of the line. So we join them, and now we have the labor constraint. So this line is actually the labor constraint line, the labor constraint line. And the line itself is when the equation is equal to. And the line plus the space. So the labor constraint area, this whole labor constraint area is the line plus the space, and that is when it is less than or equal to. So when it is less than or equal to, we are talking about the line and the space. Okay, let's go to the second constraint, which is a milk constraint area. Okay. Now, the milk constraint area, how do we generate that? The same style. We're going to write the milk constraint itself. And then on the basis of that, we try to generate that one as well. The milk constraint is given by 4x1 plus 3x2. Instead of the less than or equal to, we are going to make it straight away equal to, because we understand why. This is just to write it. And then we ask ourselves, if x2 is 0, what is x1? Tell me the answer. If x2 is 0, x1 is 30. Fantastic answer. So once you know that x1 is 30, come to the x-axis here, okay, and indicate some 30 here. That's it, 30. You should be doing this whilst I'm doing it. Then, what if x1 is rather 0? What will be x2? If x1 is rather 0, what will be x2? X2, hey, am I getting the right answer? X1 is rather 0, x2 is 40. Okay. So you move up here and you identify the 40. Right. So once you have the two, you join the two lines. So you take the 40 and you join that 40 with a 30. Okay. And once you do that, you are sorted. So this line is the milk constraint line. Milk constraint line. So you can see, watch carefully. You will notice that if we are to look at this page, the labor constraint area is what I am trying to shade. All of this area here is labor constraint area. Okay. Labor constraint, labor constraint, labor constraint, labor constraint. Then the milk constraint area. The milk constraint area includes all of these areas. Okay, all of these. All of this. Where I have to make sure that I do not go beyond this line. Okay, all of this. So you can see that there are some portions of the milk constraint that is not in the labor constraint. And there are some portions of the labor constraint that is not in the milk constraint. Do you realize that? Now, the area that is common to both the milk constraint and the labor constraint, the area that is common to both is called the feasible solution area. The area that is common to both constraints areas is the feasible solution area. Now, I'm coming to indicate some points, some names, so that we can see whether we can identify this feasible solution area. Okay, so we know that the origin is O. Okay, so the point here, I'm calling it A. The point of the intersection there, I'm calling it B. And the point of the intersection here, I'm calling it C. And the point of the intersection here, I'm calling it E. The point of the intersection at the 40, I'm calling it F. So who can tell me the feasible solution area? Yes, Judy, you have a question. Ask a question.
No, not a question. I wanted to give the answer to your
Right.
question. Okay, so the feasible solution area is A, B, and then I don't know whether I see you've drawn the one by the 20.
Yeah, I'm talking about an area, so you've not finished.
No, so I'm trying to, I mean, I see a 6
Not
there.
that number. I'm not talking about that number. That number is C.
No,
But I'm saying that you've still not finished.
okay, so the area is A, B, and C.
No.
Inside that area where we have both the stars and
I know what you're
XX.
talking about, but it's the area, it's not A, B, and C. Don't worry, you go and think about it and come back again. Let me ask Philip to tell us. Philip, what is the area?
So A0, A, B, and C.
Perfect answer. So there's a difference between these answers. You see, if this was a multiple choice, okay, that is where the thing can crack you. It is 0, A, B, C, not A, B, C. If you don't include a 0, you do not have the area closed. It has to be closed. So when somebody says, this is my plot, and then my plot, the corners of the plot are A, B, C, then the other one is bagaja, like that. Then we don't know where the plot is closed. All right. So that is a feasible solution area. Now watch this. the feasible solution area has got vertices. These vertices are called corner points. Okay. Who can tell me the vertices or the feasible, let me put it there, the sensible vertices of this feasible solution area? Who can tell me the sensible vertices? You know a vertex? A vertex. What are the sensible vertices of this feasible solution area? Belinda says A. No. What are the sensible vertices of this feasible solution area? Derek. What are the vertices?
The feasible vertices, the very first one I'm seeing 0, 20, then 0, 30. And
No, you're going too far. I'm only asking you to tell me because I've represented the vertices with the numbers, with letters. So what I need are the vertices. Just representing the, I use the word sensible. Okay, so that word sensible is also very important. Not just feasible, but sensible, reliable vertices. That's what I mean. Let me see whether Vincent can tell us. Yeah, Vincent. Where are the reliable vertices?
Reliable vertices. O, C, O, B.
Why do you have to mention the O? Ignore the O. So ignore the O. The O is not reliable. That's why I said reliable.
Okay. So
otherwise, I could have just said vertices. Give me the vertices.
Okay, then I'll allow.
Okay, Rebecca. Oh, it's not Rebecca. Okay, Philip, tell us the vertices.
Okay, so a C, B, and A.
Correct. That's all I need. So we have C, B, and A, or ABC. So these are the vertices. Now, remember our goal is to find the X1 and the X2, the sachets of fine yogo and fine chocolate. Now, which one? This optimal, solution area. Okay. The optimal solution area is this whole section here. Okay. That is the whole section there, the OCBA or AABC. So one of the vertices is your answer. One of the vertices is going to be the optimal solution point. Note that the optimal solution point is made up of X1 and then X2 coordinates. That is the optimal solution point. So in order to know which quantities or how many sachets of fine yogurt and fine chocolate to produce, you need to know the coordinates of all the vertices there. You need to know the coordinates of all the vertices, excluding the origin, because the origin is not where we are going. So how do you get to know that? Let's try and get the first one, A. So we need to know the coordinates of A. That's what I mean. We need to know the coordinates of A, X1 and X2 coordinates of A. We need to know X1 and X2 coordinates of B. We need to know the X1, X2 coordinates of C. We need to know them. So let's start with the A. Who can tell me the X1 and X2 coordinates of A? What are the X1 and X2 coordinates of A? I hope you watch the videos. Florence, X1 and X2 coordinates of A. Okay. X1 and X2 coordinates of A. Najeli, Rebecca.
It's 30, 0.
30, 0. That's it. So for X1 and X2 coordinates of A, the values are 30, which is X1, and then 0, which is X2. Okay. Now let's leave the B for now because it's a little bit complex. Let's go to the C. What are the coordinates of C? Who can give me that of the coordinates of C? Coordinates of C. Rebecca or Saku?
0, 20.
Yes?
0, 20.
0, 20. Okay. So Rebecca says it's 0 and then 20, and that is also correct. Now, if I ask you to tell me, let me show you here. Tell me the coordinates of B. The only way you can read for me the coordinates of B is go to the B, draw a line downward. Okay, let me use a different color here. Go to the B, draw a line downward, and then go to the B again, and then draw a line that. Okay. So if I were to ask you, tell me the coordinates of B, what would you say? You can tell me the coordinates of B. You can't tell me the coordinates of E. If you're able to tell me the coordinates of B, you are jumping the gun here. Whatever you say will be wrong because you can't use your eye to tell me the coordinates of B. So the only way you can get to the coordinates of B is by solving that equation simultaneously. Because when you look at the point there, the information here means that you can only get to the point here by solving the equation simultaneously. Which equation? Go back here and you see that these are the two equations. Okay, so when you look at these two equations, that is what you are going to solve. These two equations, you're going to solve them simultaneously. And we can solve them simultaneously. Okay, and whatever values you get will be the coordinates of A and B. So how do you solve the equation simultaneously? You can use the substitution method or you can use the elimination method. I expected you to have done this already using last week's revision. So if you use the substitution method, let me just go back here. Okay, I'm just going to scribble through this. If you use the substitution method and you solve it, you're going to get something like, if you take the first equation and the second equation, and then you make the first equation the subject, you're going to get x1 equal to 40 minus 2x2. That's all you're going to get for the first equation. And then you drop that into the second equation. So the second equation is going to be 4 into bracket, that x1, which is 40 minus 2x2, okay, plus 3x2 equal to 120. That's how you're going to get it. So if you go, you can check. So on the basis of this, if you multiply this and get a 160, okay, if you get 160 here, and then you get 8x2 there, you get plus 3x2, and you get 120. If you group like terms, you're going to get 5x2 equal to 40, which means your x2 will be 8. So if you do this simultaneous equation, you're going to find x2 to be 8. Okay, what about x1? Now that you know the x2 to be 8, you can drop that here, wherever you see x2 inside this equation. So wherever you see this x2, you're going to make it 8. So you're going to have 40 minus 2 times 8, which is 16. So 40 minus 16, which will give you 24. So the x1 will be 24, while the x2 will be 8. I know some of you have solved it already. Therefore, the coordinates of B will be 24 and 8. So now we know all the coordinates of A, B, C. One of them, not both of them, one of them is going to give you the optimal solution. Who can tell me any story that can help us to find which of them is the optimal solution? Who can tell me any of them, that how you can find which of them is the optimal solution? Who can tell me? If you have done the reading, you should be able to tell me something. How do you determine which can be the optimal solution? Philip, tell us something.
All right. So in the first scenario, we are looking at when we have only we are producing only one a yogo or choco, where we are not producing the other one, then that is for the A. For C2, we are producing one of the products and not producing the other. But for the B, this is where we are utilizing the two resources we have. That's the labor and milk to get the maximum yogo and choco.
Okay, I know where you're coming from, Philip. That's a nice try, but I can tell you that that approach will be wrong. In other words, what Philip is saying is that anytime some of them, what if all of them have got values? And you will get that also in further questions and real life. What if all of them have got values? And by the way, you are going to check the textbook and you will notice that sometimes some of them have got 0 and a number, and they are rather the optimal solution. Sometimes some of them have got number and a 0, and they are rather optimal than those that have got both numbers. So that is not the reason. That there's a very systematic way to find the optimal solution. Let me go to Kwejo to see.
Sir, so first you take the total profit of the farm milk. That is Z is equal to 40x1 plus 50x2.
Stop there.
And then you put...
Stop there. So now you are going on the intelligent right path. So I need to stop you there so that I can show them what you are saying. So the first thing that Kojo says is that we need to go to the profit function. That's your charger. That is your mother. That is your father. That is your uncle. Go to the entire profit function, which he said is 40x1 plus 50x2. Kojo, I've written that. Box on.
Yeah, so for our A coordinate, we have 30 and 0. So you place the 30 and 0 into the profit equation.
Thank you. So Kojo is saying that I should now go and find the Z value for A. Z value for A. So I should drop the 30 wherever I see the X1, and then I should drop the 0 wherever I see the X2. So you're going to have 40 times 30 plus 50 times 0. Could you continue?
Yes, and that will give you 1,200.
So that will give you 1,002. Box on.
Yeah, so you do the same for the Z subscript B. Using the B coordinate.
Using the 24 and 8.
Yes.
And then?
That will give you 1,360.
That will give you 1,360. Good, continue.
And you do the same for the C coordinates. That's Z subscript C. Using the 0 and 20. And that will give you 1,000. So looking at these three, the highest is the one that you pick as the optimum.
Fantastic. So what I want you to do, Kojo, is that I want you to identify Miriam. Miriam is a co-host for this. Send him your ID and full name. I'm giving you 3 marks for this beautifully consolidated effort you put into generating the answer. These, you are the creme de la cremes. You are the alphas and the omegas in this class. You are the people who are the engineers, the movers and shakers of the class, the quantum analysts, the data analysts, the machine learners. You are the ones who should be befriended than those that have been befriended in this class. And if people will learn from you and learn ahead like you have done, because there is absolutely no way you will be able to give these beautiful answers if you have not learned. I'm sure you learned before coming.
Yes, Doc.
Okay. So Ben is 3 marks for this gentleman for that fantastic execution that he has done there. So that is exactly what Kojo has indicated. So what you do is that after finding the A, B, C, now you select the one with the highest profit. Remember, all of them are profit. And you can see that the coordinates B, that is the one that gave us the highest profit because we are maximizing profit. Therefore, the optimal solution point is 24 and 8. So in executive language, in business language, you are going to now advise management of Farmer Garden Limited. What are you going to advise them? who can raise a hand and speak the business language? And let me see. What are you going to advise them? What are you going to tell them? Well, how are you going to advise them now, given all the solution that you have? Oh, by the way, if you have not prepared before coming into this room, I'm sure by now you are seeing stars. Okay. So whenever I talk on the pages that you should prepare before coming, you will now appreciate why I say that. If you've not watched the video 3 times, you should always do it like that. Watch it 3 times before coming. Philip, I'm sure you got some answers for me.
Yes, yes, Doc. So if we are making available 24 24 liters of I've forgotten the chocolate in there, but the X1 and X2 are the materials that we need to provide. If we are providing.
Okay, thank you, Philip. Philip, if you are advising management and you start talking like that, and you tell them, I don't know what I'm supposed to do, I don't know what we are doing, obviously management will tell you, go and consider the appointment terminated. Okay, let me see whether another person will be able to tell us what is going to be your practical implication, managerial policy implication that you are going to give regarding this whole analysis. You finished, you've gotten your optimal solution. Conrad, tell us something, Conrad.
Okay, thank you, Doc. My answer to the management will be, if Fan Mill Ghana Limited produces 24 Fan Yogo and 8 Fan Choco, it gets 1,360 cedis.
That is good. Next time, just add the units.
Okay.
24 units or sachets of Fan Yogo and 8 sachets of Fan Yogo. So you're telling management that if they should do that, they are going to get the maximum sachet, the maximum profit for their company. If they do anything other than that, they will never ever make the maximum profit that they want to make. Because after all optimization algorithms taken, that is an optimum situation, an optimal situation that you have to go through. And this is what you're going to advise them. And when you advise them that, you're going to tell them to apply that for 1 year. After 1 year, they will come to you and give you more money for consultancy for giving them that advice, because they would have yielded the maximum profit they've never realized before. Of course, life is complex. So there are so many things that have to be considered in addition to this. Okay, any question on this so far? Because we are going to go into the next level. Any question? So please note that those of you who thought that the ones that are having 0 shouldn't be, it's not all the time. You will later go and work some of the things and you see that the optimal solution is supposed to be 0 and 48. So sometimes 0 can be there. Sometimes the recommendation is not to produce one of the products, because that's the only way you can make even the maximum profit. So take note of that. All right, any question? So Mina has written a very nice sentence that Fan Mill Ghana Limited should produce 24 sachets of yogurt and 8 sachets of chocolate in order to obtain the maximum profit of 1,360. You got to mention that. You got to mention that profit they are to obtain. They are going to obtain, because that's you can't say in order to maximize profit, but you have to what profit. Okay. So they should know. Okay. Now, let's go back to the story and let's get deeper. I want you to look at the equation that we had. Now that we have this equation, Z max equal to 40x1 plus 50x2, and this was subject to x1 plus 2x2 less or equal to 40, 4x1 plus 3x2 less or equal to 120, and then you have the non-negativity constraint there. Okay. Now, Now that we have the values of the coordinates, there are some few things we need to ask. I can ask you, and you can be asked this question. You know the constraint that we have here? We have the labor constraint, which is the first constraint, and then the low constraint. You can be asked this question, okay? At the optimum level, which constraint is binding? Okay, which constraint is or are binding? Which constraint is binding? You got to put that point now. So which constraints or constraint is binding? Kojo, you have a question? Let me see whether you have a question. Yeah,
Kojo, it's not a question. I thought you're asking for the answer or something.
Okay, we'll come back to that. So, but you tell me, what is a binding constraint? Who can tell me what is a binding constraint? Yes.
Should I continue, Doc?
Yeah, continue.
Yeah, a binding constraint is where the left-hand side of an equation is equal to the right-hand side of the equation.
Excellent, beautiful. Okay, if people are not going to talk, I'm going to be calling you throughout, okay, and giving you all the marks, which means you're going to increase the marking scheme on and on and on and on and on like that. Okay, so a binding constraint, okay, I'm giving you 2 marks for that, by the way, so you get an extra 2 marks for it. So a binding constraint, he said it so perfectly, is where the left-hand side of the equation equals the right-hand side of the equation. That's the first one. If you didn't know, document it, put it down. What again can you say about a binding constraint apart from that one? If you know, you raise your hand. What else can you say apart from what he has said? There's something else you can say about a binding constraint. What can you say as well? Felicia, your hand is up. Yes.
Doc, please. That is when all available resources to has been used.
That is when all available resources have been fully utilized. That is also fantastic. As well. So Felicia, just document your marks down. So when all the available resources have been fully utilized, that is the available equals the usage, that is also a binding constraint. There's something else as well. What is a binding constraint? So please take note of this. There are 4 points to note. So what else is a binding constraint? Kojo, I'll come back to you. But what else is a binding constraint? Don't write it. This is where you have to talk to me. Okay? This is where I need you to talk to me. What again is another way of looking at a binding constraint? A binding constraint. A binding constraint. Kojo, was your hand up? If you have another way of saying it, you raise your hand. What is another binding constraint? A binding constraint. What is that? What is another way of explaining what a binding constraint is? Yeah, let's see. Yeah, could you?
Yeah, so Doc, looking at the 3 equations, the one that has the highest profit.
A binding constraint, well, in this context, the one that has the highest profit, but sometimes some of them will have a binding constraint, but they may not necessarily have a higher profit. So hold on to that latter part. Okay. Pius, a binding constraint.
A binding constraint is the one with the optimum solution graphically and then with the highest profit.
Oh, Pelechi Gaffa Pius. I like the way you are putting the grammatical construction of your human dignity together. That's a nice try, but you have to drink water first. This one doesn't carry anything yet. So come back again, meditate and cogitate. What is a binding constraint? Let me give you the other 2. Okay, you've mentioned 2. Now, if you don't know, be putting these things down because these are IA questions. Okay, a binding constraint. Frimpong says he has another answer to give. Yes.
Okay,
Frimpong.
Thank you very much, Doctor. Okay, binding constraint is whereby both material and human resources or labor is maximally used to achieve profit.
I love the alacrity with which you combine the grammatical, hellos together. That's a very nice one. But I can tell you with utmost respect that it doesn't carry any ice water for now. What is a binding constraint? Okay, so two more things. A binding constraint is where that constraint has no positive slack. Okay, so a binding constraint is a constraint that has a zero slack. The constraint has a zero slack. And what is a slack? If you can remember, and Kojo, you were the one who mentioned the left-hand side. A slack is equal to when the right-hand side of the equation minus the left-hand side of the constraint equals 0. That is a slack. A slack is when the available minus the usage equals 0. That is a slack. And of course, if the available minus the usage is 0, then it means that the left-hand side and the right-hand side are equal. So another way of defining a binding constraint is that constraint where there are 0 slacks. Of course, what is a slack? A slack is a wastage. A slack is an unused resource. In case you don't know, you should put it down. So that resources you are supposed to use, but you did not use, is unused. Unused resource. That's what I mean by a slack. An input that has to be. So suppose you had 8 hours to work, but you went to the workplace and arrived there at 4 p.m. and you got to leave at 5 p.m. You've already wasted 7 hours. That 7 hours is a slack. You have punished the company. You are making the company inefficient. That's not good. So we want every employee to generate 0 slack. If you generate a 0 slack, it means that you are efficient, and therefore you are making the company efficient. In other words, all the available resources at your disposal have been fully utilized. The left-hand side of this equation, if it is equal to the right-hand side of this equation, then we have a 0 slack. So that is another way of considering a binding constraint when the slack is 0. The last way, and this one you look at, you get a better understanding when we come to the computer software. The last way of looking at a binding constraint is when we have a positive shadow price. A positive shadow price. Just keep it down. When we come to that point, I'll tell you, when you have a positive shadow price, of course, you need to understand shadow price before we get through all this, but for now, hold it. When you have a positive shadow price, then we have a binding constraint. Okay, so how do we know whether the optimal solution point we selected, the point B, the coordinates of that point, how do we know that it gives us a 0 slack? Well, there are just one way we can look at it. We are going to take the coordinates of A. What are the coordinates of A? The coordinates of A are 30 and 0. And then we're going to take the coordinates of B. So A are 30 and 0, and then B are 24 and then 8. We are going to put them back into the two constraints, this labor constraint and then this male constraint. And then when we put them in, we are going to check, and that's on the left-hand side, whether it is equal to the right-hand side. If it is equal to the right-hand side, it means there is no slack. So let's take the point A, 30. When you drop the 30 into the labor constraint and you drop the 0 into the labor constraint, what value do you get in when you sum them? When you drop this 30, okay, and then you drop the 0, when you drop both of them into the equation, what do you get? What do you get? What value do you get? Yeah, and I just hope that you are following, okay? I just hope that you are following. So let's see. Now, Jerry, do you have something for us?
So when you put A into the
you sound very far away.
Constraint, when you put A into the labor constraint, it is not equal to, it is less than 40, it's not equal to 40, so it means there's a slack.
And yeah, I was only asking you to even tell me the number, and that one you didn't even tell me the number too.
10, so 10.
When you put the coordinates there, you get what
so
value?
So you get 30 plus 0 because 2x.
So you get 30
because x is 0.
So
yes,
you get 30. But I had 10. Okay, so you get 30.
Oh, okay. So okay.
That is what you get. You get 30. So because you get 30, it means that there is a slack of 10 in there. Okay, so that is it. What about when you put it into the second constraint? What about when you put it into the second constraint? What do you get? Michael.
So you get 120.
You get 120. So is there any slack there?
No, sir.
Exactly. So when you do that, even though you are not generating, what do you call it? Even though you are not generating any slack in the milk, you are generating a slack in the labor. And as long as you are generating a slack in the labor, it means that there is some inefficiencies going on in the labor side. And that's a problem, eh? That's a problem. Well, Kojo said it clearly. That is probably why that point, the coordinates of A were not selected. So let's go and do the same thing with B. Do the B, put the coordinates of B into both the labor constraint and the milk constraint, and tell me whether the left-hand side equals the right-hand side and whether they are generated slacks or not. Are they generated slack when you do that? Michael. Okay.
So,
yeah.
With the labor, the number of hours, there will be no slack, and also with the gallons of milk, there will be no slack.
Exactly.
With the B.
Exactly. Excellent work. Okay. That is good. So I'm giving you 2 marks for that. So there is no slack when you drop the coordinates of B into the constraint. So it means that no wonder that gives us the optimum, profit. Therefore, that is an optimal solution point. And that is a very good. So you are able to use the slack to help you to know that you are doing very well. Not just you are doing well, but very well. The slacks will also reveal the problem and all the situations to you. Okay, at this stage, we can write the standard form of the equation. Any questions so far? Any questions so far? Any questions so far? Whew. Very good. Those people who are prepared, you are really enjoying. Okay, now, every year I give you this question, so I'm going to try it on with you. Now, the formulation we have done today, as you can see, Z max equal to 40x1 plus 50x2, blah, 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 blah. All of this formulation is known as the non-standard form. Non-standard form. So the formulated equation is known as the non-standard form. Now, why is it called a non-standard form? The non-standard form, and you want to take note of what I'm saying, the non-standard form does not incorporate slacks in the formulation. The non-standard form does not include slacks in the linear programming problem in the formulation of the LPP. It doesn't include slack. But the standard form includes slacks. The standard form includes slack. So what I'm going to do is I'm going to convert the non-standard form right here into the standard form. And I'll be talking to you about it because it's very important. And I'll give you an example right here for you to do the same thing for me, submit it to me here privately for 5 months. Now, what is a non-standard form? Let me write it again. The non-standard form is where you have Z max equal to 40x1. I'm repeating what we've done, plus 50x2. Okay. Subject to x1 plus 2x2 less or equal to 40. And then we have 4x1 plus 3x2 less or equal to 120. And then your x1 plus x2, which is a non-negativity constraint. So this is what we know already. Now, the non-standard form is what I've written. The standard form, that one, it uses the slacks. And the slacks are represented by things like S1. So slack 1 is S1. Slack 2 is S2. Slack 3 is S3. Slack 4 is S4. Slack 5 is S5, and on and on and on. Now, these slacks, we know what they are. You've come to understand that the slacks are unused resources. Okay, we know where they are. So we know that these slacks are unused resources. We are going to incorporate the slacks into this equation, which changes the way the equation is written. And it changes the way the equation is written in 4 areas. Follow me. The first thing is that before I do the first one for you, I want to ask you. So the first is how you introduce the slack into the objective function. So guys, before I do that, tell me something. What do you think is the contribution of the slack to the objective function? Or what do you think is the contribution of the slack to the profit function, to the Z function? So this is a Z function. What do you think is a contribution? What does a slack do in this objective function? What does this slack do? And you have to think about why. By the time you give the answer, think of why. Think of why before you give. Yes, Pius.
Thank you, Doc. Doc, please, does not contribute to the objective function.
Why?
Because that resources are there, which are unused. So there's no, in any way, the company does not sell or sell those items, so or are not used, so it does not contribute to the profit of the company.
I don't get it. Give me an example.
Like for instance, when we talk of the milk constraint, you know that there are some slacks there. So it means those hours are not.
You are talking about milk. You've changed to hours.
Oh, sorry, the gallons. Like we have some gallons which are not being used. So it means that it does not in any way contribute to the profit. It has been wasted, or it does not contribute to the company of making profit.
Very good. At least I can see you have some idea there. Okay. You have some idea there. I'm going to give you 2 marks for that attempt because you got the idea. It's not perfect for me. So here's the thing. If you are supposed to work 8 hours a day, okay, and then you got to the company, and instead of working 8 hours a day, you did not work 8 hours a day. You got there at 4 p.m. and so you worked only 1 hour. What is the slack number here? Type it there. Type it there into the chat. How many slacks have you generated for the company? For not working that 8 hours, you've generated how many slacks? 7 hours. Good. Excellent. So you've generated 7 hours slack. That is waste. Now you can tell the company that, oh, boss, I'm sorry. I'll try and come tomorrow very early at 3 a.m., work all the way before the job time starts, and then after job, I'll work all the way to make up the timing. No, it doesn't work that way. You have not negotiated that. So that 7 hours you put into, you uselessly did not bring into the company, it's gone. It's gone. It's not going to add to profit. And we are not technically saying that it is going to take something from profit. It's simply not going to add to profit. It will punish the organization because it's already taking something out. Therefore, whenever you are introducing the slacks into the objective function, you will attach the number 0 to the slack. So if it is slack 1, S1, you write it as 0S1 in the objective function to indicate that it is contributing nothing to the objective function. You get a point? You will indicate that it is contributing nothing, absolutely nothing to the objective function. Now, how do you know how many slacks to include? Well, you know how many slacks to include depending on the number of constraints. Please pay attention here. This is deep. In the Formulating Ghana Limited, how many constraints do we have? I know some of you are going to be slightly confused. Who can tell me? In the Formulating Ghana Limited, how many constraints do we have? You can see that in this equation here. How many constraints do we have? Some are already confused. This one, I don't need an answer. Type it there. How many constraints do we have in this Formulating Ghana Limited? How many constraints? I hear 2, I hear 3, I hear 2. Some are confused. So it is 2, it's not 3. The non-negativity constraint is already a standard. It's not considered as any contributory constraint. It's already there. And so even the Excel, when you're doing it in Excel, you don't have to formulate that. Excel automatically knows that there must be non-negativity, so it plants it into it. So you just have to click somewhere to ensure that it's there. So there are only 2 constraints, labor constraint in this context, and then that. Now put this down. The number of constraints equals the number of slacks. The number of constraints equals the number of slacks. Therefore, since the number of constraints equals the number of slacks, how many slacks do we have in the Formulating Ghana Limited model? How many slacks do we have in the Formulating Ghana Limited model? So if I'm writing the objective function, I'll write Z max equal to 40x1 plus 50x2, 40x1 plus 50x2 plus the slacks. And we all know that the number of slacks in this model is 2. Okay, so knowing that is 2, we are now going to write plus 0s1 and then plus 0s2. That's it. As for the 0 in front of it, you understand why we made it 0. So that is how you introduce the slacks into the objective. Remember, we are writing the standard form. The standard form. Okay. Now, how do you introduce the slacks into the constraint? So you bring your subject to. How do you introduce the slacks into the constraint? The slacks, and you want to take note, the slacks will change the inequality symbol to equality symbol. The slacks will change the inequality to equality. So let's take the labor one. Remember, there are 2 slacks. The slack 1, S1 is for the constraint 1. The slack S2 is for constraint, the second constraint. So the first constraint should be written as X1 plus 2X2. Then you add plus S1, that is a slack. Then instead of the inequality, you make it equal to 40. This is how you introduce the slack S1 into the first constraint. So you add it, and then you change the sign to equality. Who can walk me through how to write the second constraint with the slack introduction? Who can write the second constraint with a slack introduction? Florence.
The second constraint will be written as 4x1 plus 3x2 plus S2, which is the second slack, equals to 120.
Excellent. That is it. Beautiful. So you got 2 marks for that. Okay. Now, how would you write the last constraint? Now, that one is tricky. Even now, the introduction of slacks now. How would the last constraint be? If you don't know the answer, lower your hand. If you know the answer, keep your hand up. How will you write the last constraint? That is knowing very well you are using your mind and you are not copying from anywhere in the world. How will you write the last constraint? Let me give it to Felicia.
No, please write as x1, x2, then s1, s2 greater than or less than 0.
Why? Why? It's either you've seen it somewhere, you read it before coming here, which is okay, but why? Which one? Which one is the okay? You saw it somewhere, you read it before.
Actually, I followed your lectures online.
Good. So you watched the video. That's good. That's fine. At least you are better off watching the videos before coming here than those who don't watch at all. But why? Why are you telling me that it should be written like this? What would be the simplest reason why you would have included this S1 and S2 here?
Okay, Prof, to my understanding, you see, when we write the other formula, we wrote it S1 because the non-negativity.
Yeah, that's it. So that's it. So what you're saying is that the slack exhibits non-negativity. If somebody uses, is supposed to use 8 hours, and the person misuses that and rather used only 1 hour and unused 7 hours, that 7 hours is a positive number. That 7 hours is a positive number. The least the person can do is the person does not waste anything, which is 0. So the slack is also non-negative. And that is the only way you can identify it. All right, that's good. That's good for 2 marks. Indicate that with Miriam. So ladies and gentlemen, this is how the slack can be written for our model here. Do you all understand? Because I'm about to give you one to do it right here. Do you all understand how the slack must be written? Okay, do you all understand? Do you all get it? Okay, now let me give you some rule. Remember that you had less than or equal to, less than or equal to. And that is why, okay, let me go to MKK. MKK, you have a question.
Yes, sir. I have a question. I have a problem and a question. My first problem is that because we are all muted from your end, we are not able to interact with the class, particularly at the point where you asked that, do we have a question earlier on before you move on to the slide? Because we were muted, we couldn't answer, say yes or no. So that's a problem for me.
Why is it a problem for you? It shouldn't be a problem for you. If you have a question, you just raise your hand, which you just did, and I called you.
No, my hand has been up for about 15 minutes now. You know, since the time you asked the question about whether we had is there a question?
I'm not seeing your hand raised. Anytime a hand is raised, it tells me that. So if you could also type it there in the chat, because I'm trying to write and follow the chat. So if you type it there in the chat, I would know.
Anyway, let me just go ahead with my...
All right. Those are the advantages of Zoom, by the way. Please ask your question.
Can I
ask your question?
Go ahead with my question, or?
Yes, ask your question. It looks like you can't hear me well. That's partly why.
You want me to type?
Ask your question.
I have a very, but also, my question is on the profile. The profile in real life, and I get this is academics, right? In real life, the profile, and if it's not linear, do we apply the same principles as we have been taught? My second question is that at the point in a class, you asked that there are 3 models we are going to apply in determining A, B, C, and all that. The first one, graphical, mathematical or equation, and then also computer. But it appears, I'm not sure, I need clarification on this. It appears that we are zooming more on the mathematical, or the mathematical goes intertwined with the graphical. I want that clarification because I was thinking on the graphical notes, most of the solution figures would have been deduced from the graphics. Thank you.
All right, so the mathematical goes with the graphical. Because the graphical is never going to be drawn to scale, because the graphical will never be drawn to scale with a hand. And in real life situation, you can never draw the thing, graphically. The graphical is supported with the mathematics. If you check my videos, you see that I've done the graphical part very, very solidly. And even with that, it will not be detectable with a human eye. You have to support it with mathematics to get it. As for the computer, we'll start that next time. Going back to your first question, life is nonlinear, I understand. So there are models, there are nonlinear programming problems that you can model to handle nonlinear phenomena. What we are doing is linear one. But I want you to note something very carefully about nonlinearism and linearization. You can have a nonlinear phenomena and you can linearize the nonlinear phenomena. This is practical. You can have a situation that is nonlinear and you can linearize it and use linear models to handle the problem. I'll give you a typical example to understand this. You can have a situation where your income can rise and fall. Let's say you are doing a business. Your income can rise, your income can fall. Your income can sometimes rise, your income can sometimes fall. Now, that is not a linear relationship. That is a non-linear relationship. But you can linearize the situation practically, where you are able to put some of the income in a diversified portfolio so that one, the forces of demand and supply and a constant income generation because of the diversification, you are able to now continuously raise your income, your net income, so that it doesn't always fall. So if you look at some people who are billionaires, they did not get up to become billionaires. They have actually worked consistently by doing something that has consistently been generating a consistent rising income. But before, their income was probably rising and falling, rising and falling, rising and falling. But they've not put a certain measure to linearize the entire life situation. So even though life is sometimes linear and non-linear, by the way, your salary is linear. Every time your salary goes up, okay, generally speaking, your salary is going up every month. Your salary is going up. Little is being added every month. Little is being added every month. Okay? Just that maybe you don't open your eyes. We all don't open our eyes, so we don't see that. You see that your salary is linear. So yes, it's not every time things are linear, and it's not every time things are non-linear. Situations can call for the other ones. So I hope I've been able to answer your question. All right. Any other? Okay. Now, the next thing is that I want you all to do me this exercise. before today becomes excitingly out. Okay. Now, I'm going to give you a model, and what I want you to do is I'm going to give you the model in the non-standard form. And your job is to convert it to the standard form using what I've just taught you here. Convert the non-standard form to the standard form. Okay. So that is why I asked whether you have a question. So if you have a question, then we can address it before I give you. Now, once I give you that thing, I'm going to allow you 7 minutes to write your answer down. And how are you going to write your answer? So let me give you an example. And I'm typing something into the chat. Okay. So into the chat, I'm typing something for all of you to see. By the way, when you look at this chat, you'll notice that I'm the host. So when you are sending me your results, you send it to me as the host. But suppose I'm writing Zmax. I write something like this: Zmax equals to 40x1 okay, plus 50x2 plus 0s1 for the slacks plus 0s2. Okay. Then I write, and how I did that is I held the shift key and enter and write subject to st. And then you write the x1 plus 2x2, okay, plus s1. Okay, that's the letter s1. Then equal to 40. And then the others can follow. I've just typed that thing there in the chat. Okay. So that is similar to what you are also going to do. And then you're going to send it to me. Okay. And because I am doing this recording here, I'll be able to capture everything that you sent to me. And I'll use that to grade you. Okay. But before that, I'm going to give you the whole equation that I want you to convert to the standard form for me. All right, so if you have a question, let me know. So this is an equation. This is an equation that I want to give you. The question says Zmax, okay, is equal to 30x1 plus 5x2 plus 7x3. Subject to x1 less or equal to 20, x1 plus x2, sorry, plus 3x2 less or equal to 10, and then x1 plus x2 plus 4x3. Oops. Okay, hold on. 4x3 less or equal to 40. And then, let me just, I'm going to write the next one to the right. Okay, so it's not taking two. So the last one is x3 less or equal to 5. And then the non-negativity is x1, x2, x3, greater or equal to 0. So this is the equation. This is a linear programming formulated equation. It is in non-standard form. What I want you to do is I want you to convert this equation from the non-standard form to the standard form by introducing slacks and carefully noting where to introduce the slacks. So do that. I'm going to give you 7 minutes. Okay. So whilst you are taking your time to do it, 7 minutes, when you have written it all down, then you send it to me. Please note that I'm the host, so you see the host in the list. Now you privately send it to me. Don't send it until you have completed it, and then you send it to me. The TA is also there. Miriam is there. She's a co-host there. You can also send it to her. That is, if you send it to me and it's not coming. Some might say that. So ladies and gentlemen, you have, let me make it 8 minutes. Okay, so it's 5:12. So when it is 5:20, you're back here and I will say stop work. So start. Please remember, some of you are sending me wrong thing. You are supposed to complete everything and send. So the way some of you are sending, you have already started getting it wrong. You have one option to send. So you don't send it plenty. It's one time. There's no need to rush here. It's not simple. You have to handle every equation, every constraint. All right, ladies and gentlemen, I'm sure you've all done with it. Everybody is sorted, everybody is sorted, everybody is sorted. I'm sure you've sent your results, okay? So I'm going to type the word stop into the entire journal page. And once I type that word stop, no other submitted work will be allowed. I said stop. That's when some are doing themselves giddy, giddy, giddy. As if they have all the, hey. So stop means stop. Don't send again. All right. So anything that is sent after the stop will not be accepted, like Cephas, like Florence, like Pius, all of that. You know. All right. So, ladies and gentlemen, you are now cordially welcome to the work that I gave you. And what I'm going to basically do is to try and solve it. Then you check whether you got it. You know it, whether you got it. So I'm going to do it right here so that you can follow through. Follow through. If you have a question, you may ask in the process. I can address it. All right, so what is the first thing to identify here? The first thing that you want to take note of is the objective function. The objective function is 30x1. So when you are writing it, you just write z max, okay, equal to 30x1 plus 5x2 plus 7x3 plus 0. And the word is 0. 0s1 plus 0s2. Then this is because I know the number of constraints. So s2 plus 0 s3 plus 0 s4. So how did I do that? Because the constraints are 1, 2, 3, 4. As for the non-negativity constraint, we know that it's not bad. If you're able to identify these parts here, you are sorted. That's the first thing. So you know that there are 4 constraints, so there are 4 slacks. Then you come to the subject to. Write subject to x1, then you bring the plus the first slack, s1 equal to 20. The second one, second constraint, x1 plus 3x2 plus s1 equal to 10. The third one is x1 plus x2 plus 4x3 plus the second one is supposed to be s2, not s1. So this very one here, this one there is not supposed to be s1, it's supposed to be s2. And this one will be s3 equal to 40. Then the last one is x3 plus s4 equal to 5. And then the final one will be the non-negativity constraint. So that one, after writing this, writing all this, you add comma s1, s2, s3, s4 greater or equal to 0. So some people, the mistake they would think is that they would think that since the x are 3, the s is also supposed to be 3. No, the s has nothing to do with the x's, the decision variable. It has to do with the constraint. It has to do with the constraint. So if the number of the main, apart from the non-negativity constraint, the number of constraints are 5, the slacks will be 5. If the number of constraints are 10, the slacks will be 10. Even if the decision variables are x1 and x2. So that is the first thing. The other thing is that all the symbols I gave you were inequalities. Less than or equal to. They were less than or equal to. What if there was a greater than or equal to in anything? Suppose this x1 here was rather greater or equal to 20. Then the slacks will not be plus here. No, the slack will be minus S1. So if there were greater than or equal to sign, the slack would be minus S1 equal to then the other number. So that is how you're supposed to generate the standard form from a non-standard form. Anybody that is sending me anything right now is wrong. Don't even bother. Like Saka, you are trying to send me, you know, I've started a thing long ago and you're still sending me information like that. All right, anybody with any question? Any question from anybody? Is a class rep here? The class rep right here. Okay, let me allow you to unmute yourself because. Yeah, class rep.
Doc.
All right, so I'm sure you guys, have you guys arranged and agreed on next week's meeting?
Yes.
Okay, so what is a, hold on, what is a situation